morning to all of you.
Good morning, sir.
Sir,
Yes, tell me.
sir, I have a doubt from CCNA 1.
Tell me.
Sir, can you explain me how frames are sent in a multicast way?
Yeah, see, like, can you share your screen where you got like from there? If I'll use the same content, it will be better. Like you can understand it. Like if you using like LMS from the CCNA one models. So you share your CCNA one model LMS, and there I'll explain it. Because in a generic, I'll explain
Yes.
maybe that is not maybe some of the content maybe you will be on the LMS. If you are not matching, so again you will face the doubt on that. So better do one thing to share
Yes.
the content from the LMS, and accordingly I'll explain it.
Okay, sir, just give me a
Yeah.
minute. Sir, is it visible now?
Yeah.
Just a minute. Uh, yeah, here, multicast MAC address. So main question is, usually we have only single MAC and IP address attached to a frame. So how does it determine which device exactly will it go to? This is my exact question.
Yeah, just see here, there is a source host, and you have a switch. Okay. So I hope you know that the switch contains that MAC table, right? Media access
Yes, sir.
control table, right? So under
Yes.
it, whenever any packet is sending from the host devices, so initially what it will happen, it will broadcast to each and every, ports of the switch. Okay. So suppose you have the source MAC and destination MAC. Just look at here. If you'll see this header, on there you have the source IP, destination IP, user data, trailer. Okay. So this is the frame. Okay. So when you'll go on the data link layer, so the data that will be called as a what that from the bits from the physical layer to when it will reach to the data link layer, it is called as a frame. You know that where it will be called as a frame.
Yes,
With
sir.
the
Yes, sir.
OS. Okay. So in this case, there will be a two things. Like one is the header, another is the trailer, right? And then
Yes.
in between, there will be a you will be having the source IP, destination IP, and source and destination MAC. So when you send the packet from the source host, it will goes to the switch, and switch will broadcast that message to each and every ports, right? Initially. Then what will happen in the next stage, like wherever it is mentioned that your what that source destination MAC address, right? So that PC will what the receive the message, and rest of the PC what they will discard that message. So accordingly, again, when the second message will be replied from the particular device, like those who receive the message, so it will not goes to the each and every devices. It will only reach to the destination one, because initially it will do the broadcasting, and the second time onwards, whenever you send the packet, it will reach, because in this switch MAC table, it will go to it will get to know that, like who having that the source MAC, and who is having the destination MAC. So when it will go to this port, when this PC will be replying here, so at that point of time, like just think of the first PC before the server, like you have a two server, right? So
Yes.
one PC is before the server, after that one PC again server, and then after one PC, right? So
Mm.
if when I'm sending the message from this particular device, from the host device, so when it is going to that what particular destinations, and the PC1, suppose PC1 is replying to that the switch, the switch will get to know that, okay, this is the destination for this particular PC. So whenever the next time message will come, so it will not do the broadcasting, it will directly reach to that device only. So that is the process that happen. And when it will go to the next layer, like the network layer, there will be a IP packet which will be added, the source IP, destination IP. But before of that, it will be only the communication will happen through the MAC, right? And
Mm.
when you'll go on the next layer, then only the IP part will come. So here they have mentioned the destination and source MAC. So
Yes.
accordingly, through the MAC address, and there will be also a R process will happen initially. So through the destination and source map, the switch will also get to know that, like switch has the intelligence, but it is not like a router. Router has more intelligence. So whenever in the case of router, whenever you send a message, to whom you want to send a message, and where you want to send a message, so it will goes to that particular device only. But in the switch, what happened, initially it do the broadcasting, it will be sent to each and every devices whoever connected in the same LAN. And the second time onwards, whenever the destination, like from the sender to the receiver, so receiver when reply to the sender, from that time onwards, switch will fill in the MAC detail, I mean in the MAC table, that okay, this packet is coming, this frame is coming from this receivers. So next time onwards, whenever I'll be getting the message, and where it is mentioned like source MAC address and destination MAC address, so I have the detail in the MAC table, like destination is this. If this MAC is mentioned in the destination MAC address, so I will not send to each and every PC. I will send to directly that PC where the sender is supposed to send to the receiver side. So like that way, the entire communication will happen. That's why here just see destination MAC is mentioned, source MAC is there. So like you can see 192.168 1.5, that is your what, this is your just sorry, this is your source IP address, just look at that. And MAC is
Yes, sir.
mentioned 00. So MAC having their different, like IP, if you are using 32 bits, and MAC, what is the size of MAC address, can you tell me how many bits MAC address contains? Did you read that?
Sir, I currently don't remember. It's in
Anyone else?
hexadecimal.
Size of
Uh,
MAC address?
48 bits.
Very good. So
14.
that's why if you see their address, when they are writing it now, all the bits, it is in hexadecimal format. Just see
Yes, sir.
C, E, because their size is more than 32. Because if you use the 32 bits, till 32 bit, you can use the octadecimal format. I mean, like you can use the binary, and you can convert in the decimal equivalent format. But here, if you go beyond the 32 bits, I mean, suppose you are using 48 bits. So in the 48 bits, you have to use some bits like the hexadecimal format. So that's why C and E, this type of address they have mentioned over here. And the
Yes.
source address and destination address, if you see, the destination MAC is last digit, just see, last value is the C8. The C8 is, where is C8? The C8, that will get to know from the what? From the receiver side, because this PC initially don't know the what that destination MAC address, but what will happen when this PC is sending that particular frame with the IP address, with the MAC address, and in here in the switch MAC table, entire MAC address of each and every PC will be listed. So in this case, when this PC will send a message, and whoever will receive the message, like according to the destination MAC address, so when the packet will be, when the frame will be received from this particular receiver side, so immediately switch will get to know, okay, this port is aligned with this MAC address. So that is the entire process happen. I mean, whatever data will be there, it will be sent to that particular destinations through the switch. Because generally, what will happen, the switch connect to the router, and router, when router is sending packet to the switch, after that, that is the job of the switch to send to the destinations. And in the destination, there will be a two-way will be there. One is the destination IP address and destination MAC address. So wherever ever be the receiver, so receiver two things should be there, MAC and IP. So IP comes when it is, when it will go to the network part. Before of that, all the entire communication happen through this MAC address. So in this case, like suppose you are sending some of the packet, like having that IP address 192.168.10 dot something, 10.1 or 10.2. So in this network, so what it will happen, it will check with the default gateway first of all, because that switch is also connected to the router. So it will check with that, okay, this is the default gateway, and in this particular network, how many devices were connected, who are that having that the same default gateway. So whoever will be the same default gateway, so in the same network, like as you know that, like it will be having communication between each and every devices. But the problem will arise when you are connecting two or three switches, and two or three switches are having their different networks. Like if you take an example, 10.1, someone is having 10.11.1, someone is having switch is having 12.1. At that point of time, then you cannot have directly, you cannot send a packet from the one switch to the other switch, and devices start communicating. In this situation, what will happen, it will goes through the router. So router will check that, okay, these are the directly devices were connected. So then it will send first, the message will reach to the router, and then router will again send to the another switch. And then another switch will check with that, okay, in my MAC table, like what are the entries are there. So who is having source and destination MAC address, and where to where I have to send the packet. So it will check through the entire detail from the MAC table, and then it will analyze. Then when it will goes to the next layer, I mean on the network layer of the OSI model, then it will verify through the IP address. Then there is no job of the MAC, because no MAC part has been done in the second layer only. Then in the third layer, when it will reach, then it will be verified through the IP header. So IP header source address, then you have the destination address. Accordingly, it will directly send to that particular destinations. So that's why the router is a device which will use in the network layer. Remember this. But switch is a device which is used in which layer? Tell me, guys.
Data link.
Data link.
Data link layer. So that's why all the part, the MAC part will be done in the data link layer. That's through the switch, because switch is the part of your data link layer, not a network layer. And when you reach to the network layer, then there is another device will come. That is your router. And router job is like containing that in router they have the routing table, that is called as a. In the routing table, all the detail of your source IP address, destination IP address, and accordingly it will forward to the destinations. Then it will not do the broadcasting kind of thing, because all the broadcasting part has been done in the data link layer through the MAC table. Okay, I hope it's you have understood. Who has asked this question?
Sir, just one more confusion. Basically, what
Yeah.
you're saying,
Hmm.
initially the frame is broadcasted to every device.
Yes.
It prepares the MAC table,
Mm-hmm.
and then it determines which PC it will ultimately send the frame, the multicast frame.
Yes.
So, in this frame, there is only single destination MAC and single destination IP, but there are
Mm-hmm.
bunch of devices.
Yes.
So, like how? to that get determined? That is through router. Like they have a different network altogether.
Yeah, no, no. See, all devices, like if you see this topology, so all the devices connected in the same network, right? So
Yes, sir.
they don't have different network. Like they have the same network because switch connect in the same network only. So you don't have to worry about the different network. But only thing is that when the device will reply to the switch, okay, that whoever will the destination address, according to the PC will reply to the switch will get to know that okay, this is the port FA0/0 or FA0/1 having this MAC address. That there will be entry will be there of the particular device. Did you understand? Like suppose just wait. I'll share my screen and I will explain you on the
Yes, sir.
whiteboard. That
Yes,
will
sir.
be better. Just wait. Just see here. Can you see the screen?
Yes, sir.
That is your scenario. There is a host PC. So whenever the message is coming from the host, just see host PC. So it will go to that first. Here it will be a source MAC, destination MAC. So that MAC address, each and every PC is having their own MAC address. So MAC address this PC will be also be having their own MAC. This PC will also be having own MAC. This one is having also every devices is having their MAC address. So they are having that own source MAC address. Right. So whenever the packet, whenever the frame will be sent, like message coming from this host devices, it will goes to that switch. Okay, and just understand, switch is having their own MAC table. Okay, there is the MAC table here. So in this table, there will be a source MAC, and there will be a destination MAC. Right. So just think of it. Each and every port. Suppose, just think of it when the message is coming here, right? So when it will reach to this switch, it will initially, it will, what it will do, it will broadcast to each and every devices. Okay. I mean, like suppose this is the port of 0 FA 0/0, 0/1, 0/2, 0/3, 0/4, 0/5. So whenever the message will come into the switch, what it will do the broadcasting. All people, I mean, whenever the data is coming, so it will broadcast means what? In each and every port, it will go this message. But everybody having their own MAC address. So where to where the data, the frame should be sent. Like source and destination MAC should be mentioned over here. Like suppose 008A or 9C, something like that MAC address is mentioned, source MAC, because this PC is sending, it means that source MAC will be entered. Definitely it will be there. And where to where it will be sent, right? So that destination MAC will also be mentioned. I mean, like here, that so how will it get to know destination MAC? When this packet will be replied, like suppose the message is sent for each and every devices. Okay. So to whom the message has been sent, right? So that case, in this case, what will happen? Like you have that two things, like this is about the MAC and another is your source and destination IP. So there will be in on the next layer, the IP part will come, like the source IP will be there and destination IP will be there. Like suppose you have that 192.168.10 dot, let it be 2, and this PC is having 10.3, right? So when the packet is coming, so two things will be there in their header and trail. What it will be there? Your MAC address. Initially, it will be a MAC address, because see, when the entire, all the header will be added, then only final message used to be sent, right? In a real environment, right? What happens? Like when the message is coming first from the application layer, just what you have to understand, just see. Like the top layer where the data is called as a, yes, yeah, yeah. It will go to the top layer, right? So like application layer. So in the application layer, it is called as a what? It's a like only your data only, right? Then after application, then there will be a which layer? Presentation. Then you have a session layer, then transport layer, right? Like that way. Then you have to come to the network layer, then data link layer, then you have physical layer, right? So these are the layers. So in this case, if you see, like whenever the data is coming, top three layers, it is called as a data only. When it will reach to the transport layer, what it is called? Data will convert it into which data
Segment.
unit? Segment. That is called as a segment. When it is used to the when it will come to this network layer, it is called as a packet, right? When it will goes to the data link layer, it will call as a frame, and then it will call the bits. So just understand, when you are sending a message, so you are interacting with the application. So from the application, that there will be a data. It is application, presentation, session, all those things part, that is called as a data only. Then the data will be divided into the different segments. Okay. And after the segment, when it reach to the network layer, the IP address will be added. Just remember this, because directly from application to application, data will not be sent. Data will send through the physical layer, right? When you are interacting with the application, and when you are a receiver, so data will receive through the physical layer. Remember this, not directly through the application layer. So suppose you are writing a message, you have opened the WhatsApp, you are writing the message. So your job is what? Basically you have just written the text, that's not only, and you have just um, hit enter, or you have just sent that message, right? So when you're when you're opening the application, so at that point of time, entire thing that will be called as a data only, and you don't interact with the physical application or all those layer. You just use the application. You have used the application, and you have sent the message. The next of the part is that rest of the job is of the network, where that how the data will be sent, what are the different layers that will be involved on that. Just a minute. After this, what will happen? Like when it will be coming from application, presentation, session layer, so all it is called as a data. And when you are sending a message, it is simply it is a data only. Then it is reached to the segment, transport layer. Then it will do that, like it use the protocol like TCP, UDP, and where the entire messages will be converted into the different segment, right? Then it will goes to that network layer. So in the network layer, there will be a IP addresses will be added, source and destination IP. Source and destination IP through the some router and all the devices if you are using, or layer 3 switches you are using it. So in this case, all the source and destination IP will be added. So just think of it, when this PC is sending, so your message is what? From the coming from the application layer, and now you have the source IP, source and destination IP will also be mentioned, right? This will be mentioned. And then when it will goes to the data link layer, then it is frame, and in the frame there will be a MAC address, will also source MAC address only. Destination this PC does not know. Like how do I get to know your destination address, your PC's MAC address? So I don't know. So that is the job that will be done on the switch. So just see now, when it will come from this network layer, your IP will header, I mean will be source and destination IP will be added, like where to where you have to send a message, right? And next thing is that when the message is coming to the switch, so each and every port, when the message will be broadcasting on the each and every ports of the switch, so what will happen? So there the message will reach to this particular device, that is switch, and it will do the broadcasting. So when it will do the broadcasting, so whoever want to get the message, like in the sense of there will be a destination IP address, right? So that PC will respond to this particular port. Okay, I am just receiving this message and this message is for me. So this port will get to know, okay, this PC is having MAC, because this one is also having the MAC address of something like maybe 8B is having the MAC address, let it be. So this PC, whenever they will be replying that this port has got an entry of the MAC of this PC, they will get to know, okay, this port what MAC address is having. So 8B, let it be 8B is the MAC address of this PC. Accordingly, whenever you send the next time message to this PC, you wanted to send a message to this PC. So this switch will get to know, okay, this packet is coming from this, okay, and when the switch has been replied to this, your host or that the sender will also get to know that, okay, this where I have to send a message. It is not about that what that the broadcasting each and every devices. My message supposed to go to this PC, like PCA. So the second time when the message will come to the switch will not do the broadcasting. Switch has got to know that, okay, my message should send to this particular PC, because this port has the entry of this MAC, and this message is coming for this source MAC address, and we will not do the broadcast. Directly it will reach to this PC. Similarly, suppose you want to send a message to this PC, right? So in this case, what will happen? Because each and every devices, one by one, whenever they are replying to the messages, so on each and every port, they will get an entry of MAC of each and every PC. This PC, whenever he or she will reply to that port, so that port will also get to know that, okay, this is the destination MAC of this. So the next time onwards, whenever the PC is sending a message, it will go to this PC. Like suppose this PC and this PC has not done any communication. First time they are doing the communication. Just think of it. First time this PC and this PC are doing communication. So will it happen the broadcasting? Yes or no? What is your answer?
Sir, please repeat.
This PC, let it be PC B and PC C has not done the any communication before of that. Now first time they are having communication through the switch. So will it happen the broadcasting?
Yes, sir. Happen.
Yes, it will happen. Whoever unknown device, those before of that, like they have not done any kind of communications. So on that situation, broadcasting will definitely it will happen. So that is the region, like you are using, there's so many subnetting question you have done, and there was a broadcast address we are using it. Remember this. So that is the main reason, like why we are every time are keeping that in each and every network there is a one broadcast address. So broadcasting should be done. Remember this, and that is the particular address where it will help you to advertise that particular devices in the same network. The advertisement that will be must in the switch, because whenever the receiver is replying back to the switch, then only they will get to know that, okay, in this particular port FA0/4 having this MAC address, and next time onwards only when you send a message, it will go to that particular MAC, I mean that particular interface, and it will reach to directly that where you want to send. It will not do the broadcasting but the first time. That's why whenever you are pinging that in the switch, you'll see initially they are showing request timeout. Request timeout. First message generally comes request timeout. That is the reason. And second packet onwards, it will start, replying it. Okay, I hope it's clear to all. Have you understood who has asked this question? Did you understand now?
Yes, sir. Yes, sir. Got it.
So now just look at here.
सर
Yeah, tell me.
सर जब मल्टीकास्टिंग होता है तो मैक एड्रेस का प्रीफिक्स हमेशा वो फिक्स्ड होता है फर्स्ट 3 बाइट्स
Yes.
01005E तो उससे स्विच को पता चल जाए कि सबको ब्रॉडकास्ट कर देना है बट द थिंग इज वी हैव ओनली वन डेस्टिनेशन एड्रेस वो एक ही के पास जाएगा ना फिर 2-3 होस्ट को कैसे पता चलेगा
तुम्हारा आवाज एक्चुअली क्लियरली नहीं आ रहा है, एक बार फिर से बोलो तो। एक ब्रेक कर रहा है तुम्हारा साउंड। कैन यू स्पीक वंस अगेन?
Sir, I was saying कि in multicasting, is it audible, sir?
Yeah.
Sir, in multicasting, the destination MAC address is the first three bytes is fixed 0100FE. और सर जब फ्रेम जाएगा स्विच के पास तो स्विच उसको जान जाएगा फिक्स सबको भेज देना है, तो सबको भेज दिया। और उसके बाद लेकिन मेरे पास डेस्टिनेशन आईपी एड्रेस में तो एक ही है, तो एक ही पोस्ट हो जाएगा, लेकिन हमको दो तीन पोस्ट को भेजना है ना मल्टीकास्टिंग में।
नहीं देखो इसमें क्या है, तुम मल्टीकास्टिंग का मीनिंग समझते हो तो व्हाट डज द मीन बाय मल्टीकास्टिंग, यू नो दैट मल्टीकास्टिंग का मतलब क्या है? देखो जब भी हम कम्युनिकेशन वन टू मेनी करते हैं, यहाँ पे सेंडर क्या रहेगा, हमारा सिंगल सेंडर रहेगा, और वो जो है एक ग्रुप में तुम्हारा मैसेज को पास करना चाह रहा है साइमल्टेनियसली, राइट? सो इन दिस केस यू विल सी, देखो हम लोग का क्या होता है ब्रॉडकास्टिंग में, क्या होता है
सबको चला जाएगा।
सबको चला जाएगा, लेकिन मल्टीकास्टिंग में क्या होगा, ये ग्रुप ऑफ पीसी को हमें भेजना है, राइट? तो इसके लिए हमें क्या करना होगा, बोलो सोचो।
आईपी यूज कर सकते हैं क्या?
हाँ, आईपी एड्रेस का जो है हमें ग्रुप एक मतलब एक होता है ना, बोल सकते हो कलेक्शन ऑफ आईपी, जो कि हमें एक पर्टिकुलर एक मिनट रुको, जस्ट अ मिनट। We were talking about what was the discussion was going on, multicasting, yeah. So have you understood, like just we were talking about, like whenever we'll do that broadcasting and multicasting, so in the broadcasting it will be sent to each and every devices, but in the multicasting, like single sender is sending to the group of PCs, there is a 100 PC in your same network, so I want to send a messages to 10 PCs only, or I want to send a message to 10 PC. I'll not do the broadcasting for the 100 PC, I'll just send it for the 10 PC. So in this case, how do you achieve this kind of things? So for this case, so there will be a collections of IP for the group of PC that will be assigned first, and accordingly you have to send a packet to the that particular scheme of IP where you have defined that okay, these are the groups and where you have to send a message. So it will be sent to the group of IP where the 10 devices has been allocated and 10 IP has been assigned to that. So from this process, actually that multicasting things done, not through the only Mac, because if you'll use the switch and if you'll try to do the broadcasting, multicasting, then it will not achieve. It will be sending to for each and every. It will do the initial broadcasting, but the second time onwards through the IP headers, with this help of that, then you can do the multicasting kind of things. Did you understand? I mean, you can do the one to many communication just like that.
Then there must be the all possible combinations for the IGMP.
Yes.
Okay, sir. Thank you, sir.
Sir, who stored this information about the group of IPs?
I mean, so in the routing table only. I mean, you are using the routing table now. So routing table has that that all kind of IP details, right? And source destination IPs are there in the routing table.
But
Your MAC details in the MAC table, you have the MAC details and MAC addresses. So in
but
this case, yeah, tell me.
sir, layer 2 switch does not have routing table.
No, layer 2 will not be used. So that's why I'm telling that the packet is not directly. See, why I've told you, like application to it will goes to the your physical layer. The communication is not one to one, is not happening. Remember this. Whenever you are sending message, na, it is going through the entire layers of OSI model. So have you understood all of you OSI layers, like in each and every layer what happens? Did you gone through that particular topic from your LMS? तुम लोग पढ़े हो ये ओएसआई लेयर का सारे लेयर के बारे में अंडरस्टैंडिंग तुम लोग का हुआ है नहीं पहले, क्योंकि ये क्या होता है ना, ये इसीलिए तुम लोग कंफ्यूजन यहाँ पे आ सकता है कि आपका हर लेयर में एप्लीकेशन लेयर से तुम्हारा प्रेजेंटेशन सेशन ट्रांसपोर्ट, हर लेयर में अपना एक चीजें जो है वहां पे ऐड होता है, एक हेडर ऐड हो जाता है और सबका अलग अलग यूज है। डायरेक्टली आईपी से आईपी ऐसे कम्युनिकेशन नहीं होता। जैसे हम अगर मैसेज को ओपन करते हैं ना एप्लीकेशन लेयर, तो वो डायरेक्टली एप्लीकेशन से एप्लीकेशन नहीं जाता, वो एप्लीकेशन के बाद तुम्हारा नेक्स्ट लेयर पे जाएगा, उसके बाद नेक्स्ट लेयर, वो किसके थ्रू जाएगा, रिसीवर कहाँ से रिसीव करेगा, फिजिकल लेयर, बट सेंडर को वो एप्लीकेशन लेयर से ही वो इंफॉर्मेशन पास करना होता है। तो वो सारे चीजें ऐड होते जाएगा। जैसे आईपी हेडर भी आया, फिर नीचे उसके बाद वाला जो लेयर आ गया स्विच जो यूज होता है तुम्हारा डाटा लिंक लेयर, तो वहां पे मैक का डिटेल्स भी ऐड हो जाएगा। फिर वो फिर बीट्स वगैरह में कन्वर्ट होगा, वो फिजिकल लेयर पे जाएगा। तो हर लेयर का रिस्पॉन्सिबिलिटी यहाँ पे रहता है। डायरेक्टली ऐसा नहीं है नेटवर्क टू नेटवर्क कम्युनिकेशन हो रहा है, ऐसा नहीं होता है। समझ रहे हो ना, तुम्हारा मैसेज एक्चुअली तो एप्लीकेशन लेयर पे यूज हो रहा है जो कि तुम्हारा डाटा है, लेकिन वो तो पास हो रहा है हर लेयर के थ्रू ना, right? So that's why everything will be done one by one. It's not like one to one, like you are interacting with the presentation to presentation, session to session, and then transport to transport. It is not like that. Packeted, that whatever messages that coming from the top to it will goes to the bottom, and then like when the sender is interacting with the application, it will reach from the application to the, it will goes up to physical layer, and then the receiver is getting one message. So receiver will not directly go to the application layer, receiver will receive through the physical layer. तो अब मैं अगर सेंडर हूं, मेरे को मेरे लिए टॉप लेयर मेरा क्या होगा, एप्लीकेशन लेयर, जहां पे मैं इंटरेक्ट करूंगा। फर्स्ट लेयर मेरे लिए एप्लीकेशन लेयर हुआ, लेकिन द रिसीवर के पास जाएगा तो उसके लिए जो मैसेजेस जो रीच कर रहे हैं, वहां पे वो फिजिकल लेयर से फिर स्टार्ट होगा, फिजिकल डाटा लिंक ऐसे करके मैसेजेस तुम्हारे वन बाय वन वो टॉप लेयर को जाएंगे जब वो एप्लीकेशन अपना ओपन करता है। तो ये एंटायर लेयर का कॉम्बिनेशन रहता है, एक कोई लेयर से खाली ये कम्युनिकेशन कंप्लीट नहीं होता है। अंडरस्टूड? तो did you understand, guys?
Yes, sir.
Yes.
Okay, so let's move ahead with that. So I will give you some task, like you have to go through, all of you understand that entire OSI model first of all, like each and every layer, what are the uses of each and every layer. In next class I'll ask some question, and if you will not answer then I will explain you. So I'll check with from your side whether you are able have you understood or not entire OSI layer, and if you're not able to explain then I will make you understand of each and every layer, because that is very very important. Sometime in interview, in on campus mostly, like in Cisco interview, that very easy question that they generally don't ask, like it's a very simple, like sometime may they can, I cannot assure you like they will not ask, but in on campus interview you'll see like multiple company they ask that explain me the OSI layer or TCP IP suites. Like they'll ask you like what are the four layers in TCP IP model, and OSI model having 7 layer. Can you explain that the entire suites that is used each and every layer in this particular model? Okay, so that is your job to go through that. It's already been defined in your LMS in detail. On your materials are given from the NetAcad, and they have given with the example and everything they have given. But anyhow, if you will not understand, just let me know. In the next class, I will explain you. So let's move ahead with the next topic. Our next topic is frame relay. Write the heading, all of you. WAN communication. Just write the main heading, like your WAN protocol or communications. व्हाट इज वैन गाइस? इसको तो पढ़े होगे, ये भी तुम्हारा दिया था। लैन, वैन, पैन, मैन, ऑल
Wide
टाइप
area
ऑफ।
network.
wide area network.
वेरी गुड। सो
Wide
वैन
area network.
प्रोटोकॉल होता है, देखो तुम लोग को दो चीज समझना है कि एक है वैन कम्युनिकेशन, एक है वैन प्रोटोकॉल। तो कम्युनिकेशन तभी होगा जब हम वैन कम्युनिकेशन करने के लिए हमें जो है वैन प्रोटोकॉल की जरूरत पड़ती है। ओके। सो वैन प्रोटोकॉल जो होता है, ज्यादातर इंडस्ट्रीज आजकल, ये तो फ्रेम रिले जो है बंद हो गया यूज, बहुत कम यूज होता है, बट हाँ इंटरव्यू में से क्वेश्चन पूछ देते हैं बहुत बार। और इस पे जो है तुम्हारा प्रॉब्लम भी होगा, इसमें तुम्हारा जो चेक पॉइंट एग्जाम्स जो है, यू विल फाइंड दैट सम प्रॉब्लम बेस्ड ऑन दैट, सम क्वेश्चंस विल बी मे बी आस्क्ड, राइट? सो just you need to understand, whenever we'll do the WAN communication, we use some WAN protocol. Okay. And one of the protocol that is called as a frame relay. Okay. Frame relay itself is a protocol and which works under like on top of your you can say that the physical layer and data link layer. So in this case, like when you create a link over the entire globe, like when you'll do the communication not only the in the same city or not in the same office, we do the for the larger distance, maybe different city, maybe different countries, when we have the communications. So on that case we uses wide area network communication, and for that we either you can use MPLS protocol, or you can use the frame relay. Okay, generally MPLS uses it in the industries. So here, like when you do the WAN communication, like generally for the different network communication you uses router. Remember this. So this class, it will take around 2.5 hours to complete this entire frame relay. So 50% complete I will complete today, and remaining 50% will do in the tomorrow class. Remember this. So the link, those who are absent, they will not understand in the next class. Nothing will they will understand when you go for the packet tracer configuration. Because here the first theory is very important. Then only you can do that hands-on. So just see, if you have the one router and they have the one router for another city, and another router is for again another city. Just think of it. Or another country also you can take, right? And what we will do, we will connect that frame relay to the cloud. Okay. And here you have to connect the cloud. Okay. So now just DC DT cable we will be connecting from the different router to the cloud. Okay. And in this case, like when you connect any cloud, like from the packet tracer, okay. So what are the things that you have to measure? Just that you need to understand. Okay. So here, like when we connect the different router, we directly don't connect this router through any physical cable. Remember this. In real environment, there is no physical cable involved between router to router. So I'm just virtual link I'm creating for the understanding. Remember this guy. पैकेट ट्रेसर में तुम लोग को राउटर से कोई डायरेक्ट केबल कनेक्ट नहीं करना है इस कॉन्फ़िगरेशन में। इस राउटर से मैं लॉजिकल कनेक्शन कर रहा हूं, वर्चुअल कनेक्शन फॉर अंडरस्टैंडिंग पर्पस, नॉट this dotted mark what I am writing over here, that it doesn't mean that you are connecting some physical cable. Remember this. Next thing is that, like here, if I'll use some of the IP, yeah, tell me. Was that?
So, but the serial cable that we used to use to connect from one router to another, that is allowed in other configurations. It's not in
Yes.
this one.
Yes. That is another configuration. See the different configuration. So just see. So here when I'm connecting different routers, so that there is a virtual link I'll create through the cloud, not a physical link I'll create directly from the router to router. Just for the understanding, I have marked the dotted line. Now see here, suppose I have used the IP, let it be for this router, this interface, or you can say that like one virtual link where I have connected over here. So in this case, suppose I have used the IP like 10.0.0.1. So this side it will be 10. The same network you have to use 10.0.0.2. Okay. And in this link, if I'll use the IP like 200.0.0.1, So for this link, you have to use the IP of 200. Sorry. Okay, let it be okay 20 also if you got 20.0.0.2. Okay. And for the next case, for this interface, let it be IP of 30.0.0.1/8. And this interface, the IP will be 30.0.0.2/8. So everywhere, I mean, class A IP I'm using over here, class full and class A/8. Okay. So next part is that, like, suppose you have, virtually you have enter the IP to this interface. How do you create a sub interface and virtual interface? Everything I will tell you in the packet tracer. Okay. Here in the one router, we have that, two sub interface will create it. This router also two sub interface will create. This router also two sub interface will create. And all interface will be logical interface. You will not go to a particular fast Ethernet port and you will type this IP. No, there is no need of these things. You can directly you create a logical interface and there you can assign that IP address. Okay, and this router is what that will be. Sorry, this cloud is basically used for your WAN communications, and that will create that particular wide area network environment where you can have the communication over the globe or maybe from the different cities, maybe Delhi to Hyderabad, Hyderabad to Mumbai, like that way. Okay, or maybe different you can have a communication from the Singapore to USA and then USA to India. Like that way, you can have a the communications. So now, when you'll go for this particular connections, so there are two ways. Either you can go for the point-to-point pin relay configurations. Either you can go ahead with the point-to-point frame relay method you can use, or you can go ahead with the multi-point configurations. Multi-point configurations. Multi-point configuration you can use. So the difference between a point-to-point and multi-point is like simple. Like you can have that when you will write that in the packet tracer. But there are two ways they have defined. Like simply whenever we are creating like different frames, I mean different router. So here that different points from the one router that can have the communication with the entire router. Here I connect 3 routers. Suppose I'm connecting 4 router, 5 router, or 10 routers. So from the one router, we can directly link with the all other routers. So simply in the packet tracer, you have to just create a sub interface, and then in the sub interface, just you have to mention that multi-point. Like this router is for the multiple routers, and there you can have that connection through that particular sub interface. So that thing you can do in the multi-point. But say the point-to-point is what each router should have that one-to-one connection with each and every routers. Like how is happened the mesh topology. I hope you have learned that mesh topology. You know that mesh topology?
Yes, sir.
Yes,
So,
sir.
so in mesh topology, what we used to do in each and every devices having that connection with all devices, yes or no? So they have that. There is a complex the wire. I mean, complex connections happen in the mesh, and multiple cables is involved in the mesh. But the thing is that there is a no chances of even one device will be filled, but other devices will have the communications because each and every devices are connected to one another. That is the topology that followed. The same it happened in the point-to-point also in the frame relay. Each and every devices will connected to one another. So that's why you see this device is connected to here. This device is also connected to this side. This device is connected to this router one. Let it be this one. Let me rename the router. Router one. This is your router two, and this is your router three. So router one is connected to router two as well as router three. Router 3 is connected to router 2 as well as router 1. So this type of configuration that we will be using in the point-to-point. So first we will understand about the point-to-point configuration, then we'll move to that your
Yeah.
multi-point. Another thing is that we use that LMI number, okay, in the cloud. Yeah, tell me, who is asking something?
So, but these virtual links we have assumed, right? So, how are we practically applying them?
That I will show you. Don't worry. In the packet tracer, I'll show you how do you practically you will apply. Okay. So this configuration when you'll go to the router, sorry, when you'll go to that your cloud. Okay. So in the cloud, you have to find the LMI, like it's a kind of local management interface. Okay. And two things that you have to configure. That one is that you have to choose that first LMI, and then you have to go ahead with the del C value, because here logical link we are creating. So for that case, we have to enter that the del C values. So del C is what? It's a kind of data link connection identifier, that is called as a. You can write it down. So that value will be provided by the ISP, I mean Internet Service Provider. So whenever you will be having that wide area connections, so del C value will be provided to each and every router as well as the cloud. Okay. So on the cloud, the all the del C value will be mentioned. You are not going to do anything, right? The service provider will do this kind of things. Like suppose Cisco is providing the del C values, right? LMI values, right? So in this case, they have to offer to the Geo or Airtel or the BSNL, like these are the values that we are doing for our communications. You can use this value. So the job of the internet service provider, maybe if you are using Airtel, so they will do this type of configuration. You will not do anything. Like if you will be a network engineer, if you will be a developer in the network side or network associate, so that you should know about that. Like how this thing happens. Like in future, like it will join Cisco. So you should have this type of all the knowledge, like what is Del C, what is LMI, how it is configured. Even you don't have to also configure, because that now that automated everything is happening, right? But anyhow, if there is a fault and under you some people are working, support team are there. So how do you demonstrate them? How do you guide them? So if you don't know, so you have to first you should know, then only you can instruct them, right? So that's why you have to understand this. So let's move ahead the packet tracer, and then I will tell you like how that all the LC values, LMI values, LMI that who is offering that all kind of the services based on that WAN communications. So everything I'll show you in the packet tracer now. So first we'll go for that your topology part, and then we'll move for the your command or configurations. So let me open. So here, just connect that. So one more thing, guys, if you want to, just let me show you here. And if you want, just see, I have only connected the router. But if because at the end in the real environment, what happened? Like some PCs will be also be connected, na? Only router will not be having communication, right? So यहाँ पे switch लगा सकते हो. You can add some PCs here. Also, you can connect 2 to 3 switches this side as well, and connect some devices, right? That thing also you can do. Then you can connect another switch and just add those devices, some PCs, right? So that thing also you can do. So, but I'm not making so complex configuration. Otherwise, you will not understand, or it will be very lengthy. I mean, so if you'll if you're able to configure frame relay with all three routers, so this part is every day you are doing it. So this part is very basic, like connecting one interface, giving IP to this interface, and giving IP for each and every PC, and you'll have a communication, and you'll configure that one of the routing protocol, because these are all of the different network. So you want to have the different network communication. So you configure any one of the routing protocol, EGS1 RIP you can use. And you can configure on this router, right? That you can do later on. So our target is first understand the frame relay, then we'll move for this adding some devices, switches, and having the communication. So we can check directly through the router. If you'll have the communication through the router, definitely if you'll add devices, it will have the communication. That is not a big deal. Okay. So let's move ahead with that our router and cloud configurations. Just a minute. so let's continue. Ma'am will not take today's class. I can add with that. So just see. So what we'll do here, we will connect that some router. So you can use any 3G. Am I audible, guys?
Yes, sir.
Yes. Yeah. So just connect some router here. And connect cloud. So where you'll get the cloud in the WAN emulation. Just see here. WAN emulations. If you click, you'll get the cloud. So PT cloud or generic you can use any another cloud. But this is the cloud PT. This is the PT MT. This is your PSL PT. And this is your modern. Okay, let it be cloud PT. Just connect it. So just see what we have to do next. We have to connect that from the cloud to router. Do you need to connect or not physically? The physical cable. We need to
Yes, sir.
connect or
Yes,
not?
sir.
We have to
Yes,
So
connect.
sir.
we use serial cable from router to cloud.
We'll use that serial DCE cable. So just remember this. One thing you need to understand here. Like we generally, whenever we connect that the first devices from the serial DCE cable, right? If you use serial DCE cable here, if I'll click there. So if I'll connect this side first in the router and then I'll connect in the cloud, then I have to give the clock rate in the router. But if I'll connect first in this particular cloud, that particular serial DC cable, then you don't have to give the clock rate because in the cloud itself, by default, all the interface is having their own clock rate. Okay. So you don't have to externally, you don't have to type that the clock rate and that value you don't have to assign. So whenever you are connecting serial DC cable, for the cloud and router configuration. So directly first connect the cloud and then connect router so that you don't have to type that clock rate. Remember this. So what I'll do,
Sir,
I'll go ahead with the serial zero. Yeah, tell me.
sir, we can directly use the DTE cable also. We
Yes,
don't
you
have
can.
to.
Yes, you can also use the DTE cable if you want. Okay, so just I'll connect with the router. So serial port is not. Is it there? So which port I have to connect? Serial or fast Ethernet? Just tell me.
Serial, sir.
So serial,
Serial.
Serial. So serial is there?
no, sir. You have to add from the config.
Yes. So then in this case, I need to add just to go to the physical interface. So just look at here, like it will make it power off and WIC 2T or 1P. You can add as many port you want. WIC 2T interface, wide interface card. Just add it in each and every router because nowhere we will find this. Yeah, now you can connect.
Now can you show what you did in the cloud zero?
No, Cloud Zero, I haven't done anything. I have just checked their interface. Nothing I did it. So you can add the serial interface. Let it be serial 0/0. Serial 1, 0/1 you can use or 0/0. 0/0 I have used for this. Okay, 0/1 net. But I can use the same one because it's a different interface now for the different routers. So it's not like mandatorily I have to use the 0/1 only. Just for that interface in 0/2 let it be. Okay. So this value, like whatever interface which you have connected, serial 0 is for router. Let it be router 1. Write the name router 1. Sorry, what is the change? Duplicate device. Okay, I need to change this. Already router 1 is accessed. Connected with this one is router 3. Router 3. This one is router 2. X1 is router 1. Done. So just look at here, all three routers are connected like physically with this cloud. Okay. And here what you have to do in each and every interface, you have to give the del C value. Del C value is data link connection identifier that will connect that, from the cloud to like we use that the cable DC cable, but on the real environment, how it will be connected to the del C value. So what you will do, you have to go to the configurations, click on the cloud first, go to the cloud, right, and then you can go to the configurations, right. So here we have that how many interface connected from this cloud? Three interface connected, right? Serial 0, serial 1, and serial 2. Yes or no, guys? Three interface were connected now. So these are the interface. If you click on the frame relay, so can you see this is the link that we have to add. That later on we'll do that.
Excuse
First
me,
of all,
sir.
we'll go ahead with the interface. Yeah, tell me.
Sir, in your packet tracer, which cloud type you have used? In my
Cloud
packet tracer,
PT.
in my packet tracer, it's only showing multi-user in cloud. It's not showing any other type of cloud.
Did you click on the WAN emulation? Did you
No,
click
sir.
on the WAN emulations? Cloud WAN emulations?
Yes, sir, I did that.
See what I'm talking about. Just let me show you. Just wait.
So can you show what you did after naming the routers and network?
Wait, I haven't done any. After naming the router, I haven't done anything. Just I have clicked on the cloud and I supposed to explain, but someone has asked some questions, so I have not did anything. Just look at here. What you'll do, like here, that is showing a multi-user connections. So don't use this. Actually, you have to go ahead with the WAN emulation. I have connected one, so I can show you. Share your screen.
Sir, I think there is the network device.
Yeah,
There is
under the
cloud option.
network device, just click here, network device, and below of that, can you see there is a WAN emulation here. यहाँ पे देखो ये
Okay, sir.
दिखेगा WAN emulations. This one, if you click here ना, this is multi-user connection. ये नहीं क्लिक करना. ये तुम्हारा किसी किसी पीसी में अगर नहीं दिखा रहा तो यहाँ पे क्लिक करो पहले. नेटवर्क डिवाइसेस में क्लिक करोगे तो नीचे ये सब राउटर स्विच हब्स ये सब दिखाई देंगे. उसके बाद तुम्हारा एक WAN emulation है वो भी
Yes,
शो
sir,
करेगा.
got it.
Okay, so just look at here. What I have to do next? Just go to the first our cloud, and on the cloud, just go to the configurations. The configuration, can you see there is many serial interface are there, and we have connected three serial interface for different routers. Serial interface 0, 1, and 2 we have connected, right? So accordingly, what you do, just mute it, guys. So just look at here. So in the serial interface, what I will do, I'll connect this. Just I have to mention the name, right? In the serial interface, I want to connect that the first, your router to the second router. Virtually, I need to connect, right? Through this link, serial 0. I mean, serial 0, if I'll be using over here, just click it serial 0 first, all of you. And here the LMI, just I have explained you, that is the local management interface, right? So there, what I will to do here, if I click it, there are three, service provider of finding that, providing that the LC values, right? So either ANSI you can use, Cisco you can use, Q9333A you can use. So these are the different service provider who provide that LC values, okay? For the interlink between the cloud and the routers, and creating a virtual link from the different clouds. So for that purpose, they provide this all the DLC values. Okay. So like we are using Cisco routers and the devices, so we'll go ahead with the Cisco. But if you use some other, the company's DLC values, that will also work. All are the service provider. Okay. But I will recommend you to go ahead with the Cisco one. Just click on here Cisco in LMI status or port status. Just this one also should be on. Just a minute, guys.
Sir, you are not audible.
So I was muted. Actually, I got a call. Yeah, just understand. Once again, I'll explain it. Just see here. Like suppose we are creating a virtual link from the router 1 to 2, and the delc values is what that will be given by the service provider like LMI. So whoever will be the LMI, those who are local management interface providers. So there are multiple providers you can see over here, and see Cisco Q933A, right? So I'll recommend you to go ahead with the Cisco. We are using Cisco devices, right? So just select the Cisco. And next thing is that in case of data link connection identifier, so you are creating a virtual link from the one router to second to third to fourth, one, like that way, right? So here you have to give that delc value. So delc values is what it has been given by the service provider, whoever will be the service provider, like LMI, whoever you are selecting as a LMI. So that company will provide you the delc values. But here, as per our like simple for the understanding and all, I'm just giving this value like 102, in the sense of 1 to 2 I'm having connection, so 102 I'm writing, so that easily you can understand. 2 to 3 if I'll have connection, 2 to 3 much, but 203 I will write. 3 to 1 connection, 301 I will write, like that way. But
So does it need to be 3
but this value, just a minute, this value is what basically it will be given in the real environment. It will be given by the service provider, not you will not directly enter these values. I mean, if you are an engineer from the Cisco, so the whatever the values that you will be deciding, I mean that your company will decide accordingly that value you have to provide to the customers, I mean to the client, whoever will the, I mean going to take these values. I mean maybe you will provide to Airtel, maybe you will provide to BSNL or Vodafone and whatever, whoever will the internet service provider. So you are from the LMI side, so you will give these values to them so that they will create a multiple link. Okay. Now just move ahead with that. The next one, yeah, now you can ask me the questions who are asking.
I was asking that these values need to be 3 digits strictly.
Sorry, this value?
Need to be 3 digit values strictly. Like you have done 102.
No,
That's
no,
all.
no, any value, any value. See, think of it. 3 digit value, just think in all over the globe, there are billions of users are there. So how it will be the only 3 digit? How in 3 digit we can configure for the all the users? So definitely any value it can be. Just for the understanding, I'm mentioning like 1 to 2 connection. So 102 or 1 to 2 or 2 to 1 connection, 201 like that. But value can be any. I mean, it's all integer value, but decimal will not be entered. Integer value that will be given, whole number values. Okay. So just look at here. The next values is that suppose I have added router. I'm just creating for the serial 0. Just look at here. So serial 0, what connection is having? That is very important. First, you need to understand. Like in the serial 0, which connection is established, because this value is very important. 1 to 2 serial 0, just see here, 0 0 is connected to 1 to 2 and serial 0 is connected to where also, can you tell me? This one router is connected to second router and first router is also connected to the third router na? Through this
Sir,
interface
from
serial 0.
1 to 2.
So 1 to
Router
2
1
that
to router
one
1 to 2 we have connected.
router 1 to 2 that done na already. I have mentioned over here. Can you see the screen? Is it a screen visible, right?
Yes,
Yes,
sir.
yes, sir. Yes, sir.
Yeah.
Yes, sir, visible.
So 1 to 2 I have done. Now I'm asking you the second case. In the serial 0 interface, this interface logically, just understand that. Logically, this router is connected to, just think about the previous where I in the that whiteboard I have drawn one diagram. Do you remember? This router is connected to router 2 and also this router is connected to where? Router 3 as well. Yes or no?
Router 3.
Yeah.
Yes, sir, router 3.
Link were connected. So that case, I have to again enter that another values like 1 to 3 as well. Yes or no? 1 to 2 and 1 to 3. So I'll write it here 103 and here 1 to 3. Done, and just add these values. Completed. So this two link I am creating for the serial interface. Just a minute. Call. Okay, so this is for the serial interface 0, that is done, and now we will move ahead with the second interface. This is the serial interface for this router 1, and router is 1 is connected to 2 and router 1 is also connected to 3. So I have given two del C values for this interface serial 0. Similarly, I have to give it for the which interface? Serial 1 also. Yes or no, guys? Serial 1, what I will type? Now just think and tell me the answer. And on the serial 1, where to where I have to type? This one will keep as it is, Cisco. यहाँ पे क्या हो सकता है del C वैल्यू? बताओ, सोचो. सीरियल 1 कनेक्टेड है सेकंड राउटर से, तो हमारा सेकंड राउटर
201,
201,
203.
203.
वेरी गुड. सो 221 हो सकता है, मतलब 201 ले लेते हैं, तो यहाँ पे नाम लिख सकते हो 221 हो सकता है. एक ऐड किया हमने, फिर 2 किससे, 2 किससे, ये 2 का 1 से कनेक्शन है और 2 का और किससे है? 2 का 3 से है, 3 से है, तो व्हाट आई विल
3 to 2.
3 एंड 3 to 2 और 2 to 3. अभी मैं सीरियल इंटरफेस में 1 पे हूँ, तो मेरे को 3 का नहीं मेंशन कर, पहले 3 नहीं रहेगा,
2 to 3.
2 to
2
3
to
होगा.
3.
Yeah, done. So this is for the serial interface 1 is also done. Now the same thing you have to do it for the serial interface 2. So in the 2 just sorry, किसका किया मैंने सीरियल, अच्छा 0 का किया था. ओके, 0 से स्टार्ट हुआ है हमारा, 0 का हुआ, 1 का हो गया है, अभी 2 पे जाते हैं. Let's start. So 2 is connected to the third one. I mean, just see here, serial interface 2 is connected to the third router, and the third router having the link between the second router and the first router, virtual link. So I have to create a virtual link. So how do I create it? So third to 3 to 1 पहले करेंगे, 301, yes or no? And similarly you have to go for the just write the 3 to 1, just add this, and what I'll write next, guys? 3 to
3 to 2. 302, then 3 to 2.
3 to 2, done. 3 to 2 हो गया, ये भी लिंक ऐड हो गया, डन. Now this is the what the delc values we have entered, and we have created a virtual link between each and every router. ये देखो हम लोग क्या है, फिजिकली तो कनेक्शन नहीं किए राउटर का, बट वर्चुअली हम लोग कनेक्ट कर रहे हैं सब राउटर को थ्रू द क्लाउड, है ना. अब क्या करेंगे, जस्ट नेक्स्ट थिंग्स व्हाट यू हैव टू डू, जस्ट गो टू द फ्रेम रिले. अब फ्रेम रिले में जाके जो जो वैल्यूज तुमने ऐड किया है ना, उसको यहाँ पे ये करोगे, मेंशन कर दोगे, मतलब कौन किसका किसका लिंक है, दैट यू हैव टू डिफाइन ओवर हियर अंडर द फ्रेम रिले सक्सेस. So just you can connect that link. First you can go ahead with the serial 0 and the serial 1 and so on, right? So what you will do, just simply you have to go to the serial 0 and just see here serial 0. देखो यहाँ पे कनेक्शन भी दे रहा है, मतलब जो serial 0 हमारा है उसका सब लिंक क्या है, 1 to 2 है, yes or no? सब लिंक 1 to 2 है, और serial 1 का देखो ये सीरियल 0 1 to 2 है, और उसके साथ सीरियल 1 किसके साथ कनेक्टेड है, 2 to 1 के साथ है, तो यहाँ पे सीरियल 1 कर दो, और इसका देखो ऑटोमेटिक ये आ गया 2 to 1, 1 to 2 और 2 to 1. हमें तो ऐसे वैल्यूज लेना है, मतलब एक का दूसरे के साथ, दूसरे का फर्स्ट के साथ, राइट. एंड दैट लिंक दैट यू हैव टू ऐड, just see here at the bottom of that, can you see the option add, just add it. Just see serial 0 having the sublink 1 to 2 and serial 1 having the sublink 2 to 1. Then similarly serial 0 is also connected to where, 1 to 3 and 3 to 1, that is the link is also there na. So what you will do, you have to just check with the serial 1, just see serial 1, and or you can do one thing, first serial 0 just go ahead with the third one, because third one is not, I have not been added, right. So be there in the serial 0 and just change the sublink where I have to change next 1 to 3 is automatically is coming, because we have added the delc values. So here if you use any wrong values it will not take, remember this, because you have already been created the delc values. So like right here what I will do, serial 0 is also connected to 1 to 2 and 1 to 3. So just see, it's already showing these values, 1 to 2 is showing, 1 to 3 is also showing. So 1 to 2 I have added, now I have next value I have to add 1 to 3. Now for 1 to 3 I have to change the serial name, serial values is 1 or 2 or 0, which one I have to change, guys? Can you tell me what it should be?
Serial 2.
Serial 2. Very good. Now you're understanding it, I think. Very good. Now in serial 2 if I will add, so what value it will come here, 3 to 1, yes or no? Is it correct,
3 to
this
1.
value or correct?
Yes, sir.
It's correct, right? So I'll add it these values. This one also done. Now just change this value, like we have changed from serial 0 to 2, serial 1, this one also done. Now change these values, because we will check with another interface, serial 1, right? So in this case serial 1 is connected 2 to 1, right? So 2 to 1 already I have, I think added, like can you see the serial 2 to 1 already I have been added to the serial 0, right? So what I'll do, I will change to which should I change, guys? Can you guess? Can you tell me what should be the values? 2 to 3. Very good. 2 to 3. And here what I should change? Will it be serial 2? Is it correct only?
3 to 2.
Serial 2, 3 to 2.
3 to 2. Now just add these values. Do I need to add anything else? Any other combination is left? कोई बचा है बताओ? Anything is left?
No, sir.
Now nothing is left. Done. All done. So if you check, like 1 to 2, 2 to 1 is there. Just see. हमने डेल्सी में यही सब डाला था ना, सीरियल 0 में जो डाला था, देखो यहाँ पे 1 to 2, 1 to 3 था हमारा, ठीक है। फिर सीरियल 1 में 2 to 1, 2 to 3 था। सीरियल 2 में 3 to 2, मतलब टोटल 6 कॉम्बिनेशन थे। अभी मैं फ्रेम रिले में जाता हूँ, मेरा 6 कॉम्बिनेशन आ गया। देखो 1 to 2, 2 to 1, 1 to 3, 3 to 1, 2 to 3, 3 to 1, सारे केसेस हमारे यहाँ पे आ गए। अभी अब कुछ और नहीं कर स्टार्ट। या टेल मी।
सर वो मेरा जो क्लॉक है वो राउटर 1 के एंड पे शो कर रहा है, तो कोई प्रॉब्लम है क्या?
नहीं, क्लॉक तुम राउटर को पहले कनेक्ट करोगी तो क्लॉक राउटर के एंड में शो करेगा। तुम जो है जो इंटरफेस कनेक्ट कर रही हो डीसी केबल, उसको पहले क्लाउड से कनेक्ट कर दो। अगर डीसी केबल इफ यू आर कनेक्टिंग थ्रू द क्लाउड, देन इट विल नॉट शो यू द क्लॉक। एंड इवन you have connected through the router and then you have connected to the cloud, then what you have to do, then you have to give the clock rate in the router. When you will write the command, so at that time you have to just give the clock rate.
Okay, sir. So if I change it right now, will all the changes remain saved or will they get lost?
No, nothing will happen. You can change it, but better just keep as it is. Don't make any changes. You can give the clock. You know that how to give a clock rate. Simple one command you have to type. Clock rate on that interface and just give the value 64,000 or something, whatever value you are taking. So it will work. So just see here, guys. This one, all the configuration, the logical part we have done, and the GUI interface part are all done. Now CLI that we'll do in the next class, because it will take again 1.5 hours minimum to complete the rest of the part. It's a big configurations. Okay. So what you will do, you all have to, those who have completed till that, just save this file, so that in next class again the same thing we are not going to do. We'll go ahead with the direct CLI. GUI part we all have done already. So just save it, and just in the next class we'll open from the same file and we'll go ahead with that. So make all of you just make one folder for the Cisco training, and there keep all the files. Don't save here and there. Make it in order. Okay, so remaining we'll see in the next class, guys. I hope you all are giving the exams, and guys, 29 is the last date. Make sure that you all have completed. Don't procrastinate for the last date, because so many exams are left. So if you'll on the same day, if you think that all more than 15 or 20 exam on you will give on the same day, then it will be really difficult for you. So in every week, at least 3 to 4 exams just complete, so that at the end of that you complete entire exams. So we'll see you tomorrow.